Now, if an initial sample of the element contains 1,000 atoms, how long will it take for the sample to decay down to 125 atoms? So your time must always start at 0 days. Sige nga. Please, you can do it now kasi may example na tayo last meeting. Hatiin nyo yung amount every half-life. So you start with 0 and the half-life is 3.82 days. So how many days would it take it to decay until it reaches an amount or quantity which is 125 atoms? Okay? Okay. Sino na nakasagot? Oh, Mr. Romano, anong sagot? No, try again. Okay, try again. Baka may mali ka dun sa pag-add, pag-divide mo. Yung pag-add mo or pag-multiply mo.
Ma'am, subok, ma'am.
Okay, Mr. Salvador, ano?
Ano mo, 52 days po ba?
52? Laki naman. Mr. Romano. Okay, 11.46 days. Okay, 11.46 days. So, ganito ang pagsusolve niyan. We started with, always start with 0. Itong formula na ito, this is how to determine the length of half-life para makuha mo yung 3.82. Total time divided by number of half-lives will be the length of half-life. So, huwag niyong gagamitin ito kasi ito ay this was formulated only in order for you to determine the length of half-life given the total time and the number of half-lives. Okay, so this is how you should do it. Okay, starting with 1,000. Naka-present na ba? Hindi pa.
Hindi pa po.
Hindi pa po.
Okay, tandaan nyo to ha, kasama ito sa exam ninyo. Yung seat work nyo rin, mamaya. Okay, starting with 1,000 grams. Atoms pala. Okay, so start kayo ng 0. Kasi hindi pa siya nag-decay. So, 0 days pa. Days, di ba? Hindi siya hours. Okay. So, if it, how long is the half-life? 3.82 ba yun? Tama ba, Mr. Romano? 3.82?
3.82 po.
Okay, so pag nag-half-life siya, hatiin nyo naman yung quantity. So 500 atoms na lang. So this is the first series of half-life. Yung pag-decay niya. So lagay nyo dito 3.82. Okay. Pag nag-decay ulit, kasi hanggang maging 125 yung original. So, hatiin nyo ulit to. 250 atoms. Okay? Add another 3.82 ulit. Or you can multiply this by 2. Pag third series, multiply the half-life by 3. Fourth, fifth, and so forth, and so on. So, this is 7.64 days. Okay. Next, hanggang 125, di ba, ang tinatanong. So, you divide 250 by 2, 125 atoms. Then, add another 3.82 dito sa second series. So, it becomes 11.46 days na. Okay? Ganun lang. Pag sinabing half-life kasi, the original amount is half, no? Hatiin. Tapos pag another series of half-life, hatiin nyo ulit yung amount. So you keep on adding. You keep on adding the half-life to the corresponding series of half-lives. Or you can just multiply this by 2 sa second series, multiply this by 3 sa third series, multiply by this by 3 sa fourth series. Depende kung ilang series yung half-lives. Or if you cannot do it like that way, mag-add kayo ng mag-add. 3.82 plus 3.82 is 7.64. 7.64 plus 3.82 is 11.46. Pag meron pang sumunod, halimbawa, this is now 62.5. Tama ba? Magiging 62.5 atoms na lang to. Pag mayroon pang fourth series of decay or half-life. I-add nyo ngayon. If you're going to add this, how much? 15.28. Tama ba? Tama? 15.28 days na. 15.28 days na ang mangyayari. Okay? Naintindihan?
Yes po.
Basta, ganun lang mangyayari. Now, if yung tinatanong naman is the remaining, ganun din ang gawin nyo. You keep on dividing by 2 yung quantity, tapos ito naman pa-add kayo ng i-add yung half-life. Clear? Clear tayo doon? Ano? Okay. Ano yun, Mr. Coronel?
Ma'am, kaya po nakuha yung 7.64, 11.46. Pinag-add lang po yung 3.82 tapos
Yeah, kasi this is the half-life eh.
Okay po. Gets
Every 3.82 days, mahahati yung amount ng isotope. Pag sinabi kong isotope, that is actually the nucleus. Hindi ba? Ano ba yung nagdi-decay? Di ba yung nucleus? Yung nucleus nagre-release ng nag-i-emit excuse me, nag-emit ng radioactive particles. Kaya nag-change. Excuse me. Okay, is this clear? Balik tayo doon sa PPT
Pero
natin. Ayan. Ay, na-picturean nyo ba yon? Solution. Madali lang naman eh.
pero tanda naman po.
Madali lang naman yun eh, di ba? Now, di ba mayroon tayong balancing of nuclear equations? Number 1, we have radioactive decay. Pag nag-decay at nag-emit ng particles, or pwede rin namang mag-absorb ng nucleus, or it is bombarded by a neutron or a nucleus. Pag sinabi kong if the problem states that a radioisotope, when I say radioisotope, that is actually the nucleus, pwede rin it is mentioned as radioactive element. Okay, isotope, radioactive element, nucleus, pare-pareho lang yon. So when a nucleus is, when a radioisotope is bombarded by a nucleus, ibig sabihin may dumagdag doon na isang element. That is another way of balancing a nuclear equation without considering a radioactive decay. Balik tayo doon. Papakita ko sa inyo, ha? Layo na pala nun. Ito, types of nuclear reactions. We have alpha, gamma, beta, positron.
Ma'am, hindi po kayo naka-present po.
Hindi pa ba? Palipat-lipat kasi akong presentation, kaya ganun. Okay, di ba mayroon tayong 4 types of nuclear reactions? We have decay, radioactive decay, gamma, alpha, beta, positron. Meron din tayong tinatawag na nuclear disintegration. That is the emission of a proton or a neutron. So, iba siya sa radioactive decay. Meaning, dito sa nuclear disintegration, ibabalance nyo yung protons and neutrons. Although, pag nag-emit ng protons or neutrons, yung reaction, ibabalance nyo ngayon how much neutron shall be added to the reaction para mabalance yung atomic mass sa atomic number. Diba? Dito naman sa fission, it's the splitting of the nucleus para makabuo ulit ng another nucleus. It's a chain reaction. It's not a reaction eh. It's a continuous chain, parang pyramiding. One nucleus, 2 nuclei, and then fusion, 4 nuclei, 8, 16, 32, etc. Sa fusion naman, ito yung combining, fuse. Combining of 2 nuclei in order to form a nucleus. So, yung fission, opposite ng fusion. That's what we took up last meeting. So, balikan natin itong nuclear disintegration dito. Yun yung example nating susunod eh. Ito. That is balancing nuclear equations wherein you are going to add neutron on the left side of the equation and also on the right side of the equation in order to balance it. Dito, hindi ito radioactive decay ha. This is another type of nuclear reaction. So, the sum of protons plus neutrons in the products must equal the sum of protons plus neutrons in the reactants. So, for example, we have here uranium-92-235. Na-bombard siya ng isang neutron. When you say bombarded, dito na i-add yung neutron, which will give you cesium-138 plus rubidium-96. Now, para mabalance yung reaction, 0 yung proton dito ha. 0. Kasi neutron lang yung inad mo. So meaning to say, atomic number of neutron here is 0. Wala nga, di ba? So 92 plus 0 is 92. Kasi nabombard siya. Paano mo ibabalance ito? How much neutron are you going to add on the opposite side of the equation para mabalance yung reaction? So ang basis nyo dito is yung atomic number. So tingnan nyo to, 55 plus 37 is how much? 90, di ba? 55 plus 37, how much is that? 92 na, di ba? 92, tama? Hello?
92, ma'am.
Okay. So, ibig sabihin, yung neutron na i-add mo is balance na kasi yung atomic number or the number of protons, di ba? 92, 92. So, pupunta ka ngayon sa atomic mass. Sa atomic mass. Di ba? And remember that atomic mass is the sum of the protons plus neutrons. Remember? So, 235 plus 1 is 236, di ba? 235 plus 1 is 236. 138 plus 96 is 234. Tama? 234. So, you need to have a coefficient that when you multiply it to 1 neutron, it will be 2. So, 2 times 1 is equal to 2. So, when you add 138 plus 96 plus 2, it will be equal to 236. Okay? You got it? This is we conserve the mass. We conserve the mass number. Sa atomic number naman, it's just very similar. Ang ibabalance nyo lang dito is the atomic number, which we did already here, no? We did already here. So, very similar. Actually, class, pag nagbabalance kayo ng nuclear reaction, the first thing that you need to do is check yung atomic number. Check nyo muna yung atomic number. Kung balance siya, doon kayo magbe-base. Kung hindi pa, kailangan may maidagdag kayo. So, that is how to balance nuclear reaction when you are going to consider only the number of neutrons and the number of protons. Okay? Walang decay ito, ha. It's just mere balancing of radioisotopes by making use of the addition of neutrons to both sides of the equation. Okay? Addition lang ito, ha? Now, this is now what you're going to remember with regards to balancing of nuclear reactions. Of course, atomic number is denoted by Z, that those are the number of protons in the nucleus. Mass number is the number of protons plus number of neutrons, or atomic number plus number of neutrons. Remember that, diba? Prelims pa lang, tinitake up na natin ito. So, proton is denoted by 1p1 or hydrogen 1. Neutron is 0 and 1. Electron, of course, is negative 1 E0 or negative 1 beta 0. This is actually beta emission. Positron is positive E0 or negative 1, 0 beta. The opposite of positron kasi is electron, di ba? So, pwedeng maging ganito. Basta always remember that when it is positron, positive yung electron. Positive. Pag electron lang, negative. Yung mga charges, ha, tandaan nyo. Sa alpha particle, it is 2 alpha 4 or 2 helium 4. That's what we took up last meeting. Yan ang tatandaan nyo sa balancing. Now, this is another example of nuclear reaction. Polonium-212 decays by alpha emission. Write the balanced nuclear reaction for the decay of polonium-212. So, pag alpha, you need helium, di ba? 2 helium or helium-4 or 2 alpha-4. So, ibig sabihin, when you balance it, what should be the element or the product nucleus here? So, check nyo ngayon yung check nyo ngayon yung atomic number. Check nyo muna yung atomic number. So, meron ka ng product na helium which is actually the the alpha particle. So ano yung kailangan mo para maging 84 dito? Check your periodic table. Tingnan nyo yung periodic table nyo. What element?
Alin
What
po ulit, ma'am?
What element has an atomic number when added to helium, it equals to the atomic number of polonium? Tingnan nyo sa ano nyo. Actually, may sagot na dito, kaya lang, I want you to check your periodic table. Anong element? May katabi ba kayong periodic table dyan? Kailangan yan sa exam. Ha?
Xenon, ma'am, Xenon. Ay, hindi pala po. Hindi po pala Xenon.
May sagot na nga dito. I just want you to confirm dyan sa periodic table nyo kung talagang lead. It should be lead. PB dapat. Nakita nyo? Element number 82. An element with an atomic number of 82 should be added to helium-2 para maging 84. Do you understand? Na-check na nyo ba sa periodic table nyo? Or
Opo.
Yes po, ma'am.
Okay, 82 lead, di ba? So 82 plus 2 is 84. Now, how much is the atomic number, atomic mass of lead? It should be 208. 208 plus 4 is 212. Now, take note, class, that when there is a decay, let's say, nag-produce ng isang atomic nucleus or what you call radioactive nucleus, CDK, it doesn't mean to say na it matches the atomic mass in your periodic table. It depends. Diba kasi nagva-vary ang neutrons, kaya nagva-vary din yung atomic mass. So the element here should be 82 lead 208. Naintindihan nyo? Class, just consider the atomic number tapos add lang kayo para mag-reaction. Naintindihan?
Opo. Opo, ma'am.
Sige. Now, eto. Balancing nuclear decay equations. So, what should be added? Okay, radon 222 undergoes a certain type of decay. Ang product niya is polonium 84218. What is to be added here and what type of decay it underwent? Miss Magnaya.
Helium po, alpha decay po.
Okay, alpha decay. So, helium-24, di ba? Helium-24. Para pag inad mo, 84 plus 2, 86. 218 plus 4 is 222. Okay, how about the other one? What type of decay and what are you going to add? Check your periodic table. What is element symbolized by capital P and A? It is under the actinide series. Tama, actinide series. What?
Protactinium po.
Okay, protactinium. Protactinium is a radioactive element. Okay, so what should be added? Mr. Coronel?
Ma'am, try lang, ma'am. Hydrogen po ba?
Hydrogen. Decay yan, iho. Decay. Decay yan. Nag-decay siya. Ano yung na-emit niya? Together with the radioactive nucleus. With the product. Ano yung emitted? check nyo yung ano, i-check nyo yung ano, yung atomic number. Nag-emit siya ng ano, certain particle. So ano yun? Anong particle yun? And what is the decay type? Hello? Mr. Sinsay? Ano dapat?
Beta po.
Okay. Miss Sinsay. Beta what?
Beta decay po.
Yeah, ano nga? Pag nilagyan mo sa equation.
Ano po? Negative 1 beta 0.
Okay, negative 1 beta 0 or negative 1 E0. Pag sinubtract mo yon 91, di ba negative 1 ang beta? Negative 1, magiging 90 siya. And the atomic mass is still the same. Kasi yung beta, it has no atomic mass. So it is, the decay type is beta. Okay? Naintindihan? Okay, so let us now compare chemical reactions from nuclear reactions. Dito sa chemical reactions, this is what we usually do in balancing, di ba? Nagbabalance tayo ng chemical reactions. So, in here, you should remember the difference between the two. Atoms are rearranged by the breaking and forming of chemical bonds. While sa nuclear reactions, elements or isotopes of the same elements are converted from one to another. Then, only electrons in atomic or molecular orbitals are involved in the breaking and forming of bonds. Compared to nuclear reaction, protons, neutrons, and electrons and other elementary particles may be involved. Reactions under chemical reactions are accompanied by absorption or release of relatively small amounts of energy. Sa nuclear, reactions are accompanied by absorption or release of tremendous amounts of energy. And lastly, rates of reaction are influenced by temperature, pressure, concentration, and catalyst. The rates of reaction normally are not affected by temperature, pressure, and catalyst. So these are the differences between chemical reactions and nuclear reactions. Okay, so that sums up the topic on nuclear chemistry. Okay, are there any questions regarding it? Wala. Just remember, the important thing here, yung balancing at saka yung calculations of decay, yung half-life and remaining amount of certain radioisotope. No questions? Are there any questions? Bago tayo mag-sit-work, we should try to start first yung chemistry of the environment, part 1. Actually, by part 2 ito, kaya lang there's no more time. Wala na tayong enough time to take up nuclear or what you call chemistry of the environment part 2. So, part 1 lang tayo. Anyway, this part 1 is like high school science. Madali lang siya. Wala nang computations dito. Magme-memorize lang kayo. Okay, if there are no questions in nuclear chemistry, let's proceed to chemistry of the environment, part 1. 42 slides lang to, so mga 30 minutes, we are done with this. Okay, first thing, we have to, when you say chemistry of the environment, of course, we deal with somehow the atmosphere. How can we protect our environment, considering what is happening in the atmosphere. So let us define first what atmosphere is. It is an envelope of air surrounding the Earth and bound to the Earth by the Earth's gravitational attraction. Actually, it extends from the surface into space with decreasing density with height. So there is no actual top or no real top because the atmosphere is composed of 4 layers. 4 layers. So the atmosphere is really very shallow compared to the size of the planet. It is just a thin veneer. So when you say veneer, parang if you can compare it with a thin sheet of paper, or if you can compare it with a thin peel of orange, parang ganun siya. Parang yung earth na ano lang, natakpan lang ng parang yung orange, 'di ba? Pag binalatan mo 'yon, yung balat niya, that is considered to be a veneer. Manipis lang siya pag binalatan mo yung orange. So the atmosphere is actually a thin veneer. 3/4 of the atmosphere by mass is in the lowest 33,000 feet, which is roughly 10 kilometers. Okay, 10 kilometers from the surface of the Earth, habitable until 5 kilometers. Habitable until 5 kilometers. So what are the atmospheric constituents? Ano meron sa atmosphere? So when we say that it is actually air, the composition of dry air are the following: nitrogen 78.08, oxygen 20.95, and minute amounts of other gases such as argon, neon, helium, hydrogen, and xenon. So for the most part, we have the highest percentage is nitrogen. Actually, in chemistry, we deal with hydrogen as 79% and oxygen is 21% to make it 100. Okay? Now, with that, there are still other components or constituents of the atmosphere. They are actually the variable gases. Saglit lang, class. Okay, we have the variable gases such as water vapor, carbon dioxide, methane, which are considered to be the greenhouse gases, nitrous oxide, ozone, sulfur dioxide, and nitrogen dioxide. So when you say carbon dioxide, actually, from our carbon footprints, carbon dioxide is actually a greenhouse gas. It is a very effective absorber and emitter in the infrared rays coming from the sun. So ito yung nagpo-protect sa atin. But pag napakadami na rin carbon dioxide in the atmosphere, hindi na makapag-bounce back ang heat na-emit ng sun. Instead na mag-bounce back sa atmosphere yung heat, since napakadami ng carbon dioxide, the tendency is mag-stay yung heat sa surface ng Earth that will cause global warming. That is why we are encouraged to reduce our carbon footprints para hindi tayo makapag-produce ng too much carbon dioxide. Kaya tinawag siyang greenhouse gas. Okay, si ozone naman, O3, it is good in the atmosphere because it protects us from the UV rays coming from the sun. But it is also bad near the surface of the Earth because it is corrosive. Wait lang, class, ha. Sorry class ha, medyo may ano lang, may important na ano. Okay, so let's continue. So where were we? Saan ba tayo nagtapos? UV. Bad near the surface because it is corrosive to lungs and more. So you must remember class that the UV or the ozone layer, I should say, is found along the stratosphere. Mataas na. Okay? Along the stratosphere. So we are actually protected from the ozone gas kasi nga it is bad near the surface of the earth. So another is sulfur dioxide, which is emitted by volcanoes. So atmospheric particles and acid rain actually will be produced from sulfur dioxide, and also nitrogen dioxide, which is produced from combustion that brings about acid rain and also smog. So these are actually what are present in the atmosphere. Aside from that, meron ding solid particles which are suspended in the atmosphere. Okay. On variable gases ulit, water vapor, which is 0 to 4%, is critically important. Okay. So this water vapor actually will precipitate and condense. Okay. And precipitate siya sa clouds. And it is also an important way to move energy around. And also, it is also a major greenhouse gas, water vapor. Methane also is a major greenhouse gas. Now, the non-gas constituents are the following. We have the hydrometeors or rain clouds and hail. Alam niyo ba yung hail? Na-experience niyo umulan ng hail sa lugar ninyo? Yung parang maliliit na tipak ng ice?
Yes, ma'am. Dati po, ang dami ng lagi po.
Okay.
Pag sobrang init, ma'am. Tapos biglang
Usually. Pero ngayon, parang very seldom na tayong maka-experience nito. So, particulates and aerosols are also. Aerosol is a liquid or solid dispersed in a gas, usually air. Particulates also, which can be inorganic, such as soil, smoke, dirt, sea salt, volcanic dust, surface acid aerosol, and the organic ones such as seeds, spores, pollen, bacteria. So not only bacteria, pati virus, di ba? Kaya nga tayo ay nagmamask. Kasi nga, because of airborne bacteria and also airborne viruses. Now, what are the advantages and disadvantages of particles in the air? They act as condensation and freezing nuclei. They act as condensation and freezing nuclei because water likes to condense on or freeze onto particles. They can absorb or scatter radiation also, but they reduce visibility. They can scatter solar radiation to space, causing the planet to become cold. But they can also impact human health. They can irritate the lungs, initiate asthma, heart disease, and other diseases that may be considered. Okay, these are the advantages and disadvantages of particles in the air. But before anything else, we should learn how the atmosphere developed from the first, second, and third atmosphere. But of course, there are still many uncertainties with regards to this. So we will be considering now the scientific view of how it developed. So about 4.5 billion years ago, or BYA, pag BYA, it means billion years ago, the Earth formed out of nebula of gases and dust that were to become the solar system. And also, small objects called planetoids accreted or combined together to build what you call the larger objects, such as the planets. This is the scientific side of it. Now, there came now the first atmosphere. Now, the early atmosphere before would have been similar to the sun. It consists mainly of helium and hydrogen. But this atmosphere was lost quickly for at least 2 reasons. Nawala rin yung first atmosphere na yon. Why? The gravity of the modest Earth was not strong enough to prevent such light gases from escaping to space, particularly since the early Earth was hot. Mainit pa noon ang Earth. Now, it appears that around 30 million years ago, after the Earth's formation, it was struck by a large object the size of Mars. The result, the origin of the moon and the loss of Earth's early hydrogen and helium in the atmosphere. Because of this, when it was hit by a large object, nagkaroon ng debris which tend the Earth, brought about the formation of moons, of course. So this is just an illustration of how that particular large object hit the Earth during that time. Now, this is now the formation of moon from the debris of the collision. Now, before, the Earth is considered to be hell because that time it was very hot. The surface of the Earth during this period was extremely hot with numerous volcanoes. Maraming mga volcanoes pa before. The Earth was under near constant bombardment by objects of varying sizes. Now, slowly, the Earth started to cool down and the second atmosphere began to form. So take note, yung first atmosphere consisted of helium and hydrogen only na nag-escape din nawala. So the development of the second atmosphere began. So this was the outgassing of volcanoes. Okay, so there's a lot of volcanoes before. So there came now the second atmosphere. So a new atmosphere was established by the outgassing of volcanoes. You know very well that when a volcano erupts, the tendency for it is to emit gases, di ba? The mixture of gases was probably similar to those of today's volcanoes. So kung ano yung mga gases that are being emitted before, they are very similar to the volcanoes, what the volcanoes at present do emit, no? So number one is water vapor, which is actually roughly 80%. Carbon dioxide, roughly 10%. Nitrogen, only a few percent. And small amounts of carbon monoxide, HCl, hydrogen chloride, hydrogen sulfide, sulfur dioxide, methane, ammonia, and other trace gases. So, ang pinakamalaking emission before or even now is water vapor. Water in the form of gas. So, this is just an illustration of the outgassing of volcanoes. Together with the gases are, of course, what you call the ashes or the fine particles, fine sands that goes with it. If we experience nung pumutok ang Taal Volcano, yung mga taga-Dasma, na-experience yun ba yung ashfall before?
Yes, ma'am.
Sometime 2019 bago mag-pandemic. What happened to Silang, di ba? Nearby towns like Silang, naligo sa ashfall. Even Tagaytay. Yung Tagaytay before, nagmukhang ghost town, remember? At dito rin sa Dasma, nagka-ashfall din if you happen to look at your mga bubong sa bahay, namuti sa alikabok. And also, amoy asupre during that time, just like in that particular evening, nagkaroon ng masangsang na amoy because of the emission of sulfur dioxide. Okay, so sa second atmosphere, there was no oxygen yet. Wala pang oxygen sa second atmosphere. So if there is no oxygen, wala ding ozone layer. Diba? You know very well that ozone consists of 3 atoms of oxygen. So if there is no oxygen, no ozone layer. So what happened? Ultraviolet radiation flooded the Earth's surface. Now, with the huge influx of water vapor coming from volcanoes, and the cooling of the planet, clouds on Earth's oceans form. Nag-form na ng clouds at saka oceans. At that time, the sun was about 30% weaker than today. Okay, so hindi pa masyadong nagbibigay ng heat energy ang sun. So what happened? We should have been frozen during that time. The Earth should have been frozen during that time. But why didn't the Earth freeze over? Because there is what you call carbon dioxide coming from the volcanoes. Kasama rin sa CO2 sa naiimit na gas coming from volcanoes. So it protected the Earth from freezing over. It has a very strong greenhouse effect, a protective effect sa surface ng Earth. So there came now oxygen, the rise of oxygen in the third atmosphere. So in the first 2 billion years of the planet's evolution, the atmosphere acquired a small amount of oxygen, probably by the splitting of water molecules by solar radiation. So water will split into an atom of hydrogen, a molecule of hydrogen, and a molecule of oxygen gas. Okay? Now, how was it determined that oxygen was developing that time? Because of the rust developed on the surface of early rocks. Diba, when iron is oxidized, nagpo-form ng rust. Therefore, they concluded that oxygen is already present. Kasi nagkaroon ng kalawang sa ibabaw ng mga bato. And remember that iron can be mined from rocks. Alright? And another also, the oxygen also led to the establishment of the ozone layer. So that reduced the UV radiation at the surface of the Earth. Mayroon ng ozone layer kasi nag-form na si O3 because of the presence of oxygen gas. So little by little, na-reduce yung UV radiation sa surface ng Earth. Now, also with the rise of photosynthetic bacteria, which we call cyanobacteria and early plants, oxygen levels began to rise rapidly, as did the indications of rust in rocks. You know very well that plants will absorb carbon dioxide, diba? The plants absorb carbon dioxide, and the plants give off oxygen by photosynthesis. Okay, so mayroon ng plants began to grow. So dumami na yung oxygen. So between 2.5 BYA, billion years ago, to about 500 BYA, oxygen rose to near current levels. Dumami na yung oxygen sa atmosphere. But there came a problem. With lower CO2 levels, the Earth became more susceptible to ice ages. Of course, syempre kumunti na yung mga volcanoes na nag-outgas, na-lessen na ngayon yung carbon dioxide that serve as protection ng CO2 from freezing. So with lower CO2 levels, the Earth became more susceptible to ice ages. So that's why may tinatawag tayong ice age before, when solar radiation decreases due to orbital variations. It appears that around 750 to 550 million years ago, Earth cooled down and became nearly entirely glaciated. Parang natakpan siya talaga ng snow before. And take note that one can get into a feedback with snow reflecting solar radiation, producing cooler temperatures and more snow, leading to less radiation. So how did we get unfrozen? Bakit hindi tayo nag-freeze? So bumalik ulit tayo. Volcanoes continued again to erupt, putting CO2 in the atmosphere. Diba nawala? So nagkaroon ulit. Weathering was greatly reduced, since little liquid water was also produced. I mean to say, weathering was greatly reduced. Therefore, little liquid water was also produced. Meaning to say, nag-diminish yung amount ng water because of weathering na na-reduce. So that time, carbon dioxide increased until the greenhouse effect was so large, the earth warmed up. So once warming started, it would have happened very rapidly. All right? Now, we are experiencing what we call global warming because of this too much CO2 in the atmosphere. Because of our carbon footprints. Marami na tayong CO2 emissions na umaakyat sa atmosphere. That's why as much as possible, we should reduce our carbon footprints. So the last 500 million years, the climate has not been constant, with warm periods interrupted by ice ages. Much of the variability forced by changing solar radiation due to the periodic changes in the Earth's orbital characteristics and tilt, which we may call Milankovitch cycles, and major volcanic eruptions putting out massive CO2 that caused warming. That was 5 million years ago. Okay. Now, let's take it again, more on the Earth's atmosphere. Actually, it is a thin veneer, as I've told you earlier. Now, the Earth's radius is about 6,400 kilometers or 3,840 miles. Now, if you multiply this by 2, the diameter of the Earth is about 12,800 kilometers or 7,680 miles. Nearly all of the atmosphere is contained in the layer from the surface to 100 kilometers. Habitable atmosphere, only the first 5 kilometers. So the first 5 kilometers are habitable. Basing on the surface of the Earth, based on the surface of the Earth, 5 kilometers above. So the habitable atmosphere is only 5 over 6,400 kilometers or 0.0078 or 1 over 1,280th of the distance to the Earth's center. So much thinner than the peel of an orange. That's why I compared it to an orange peel a while ago. Okay, so let us now consider the 4 layers of the atmosphere. The Earth's atmosphere is made of distinct layers. We have a complex variation of temperature with height. So the main layers are the following. We have the troposphere and the stratosphere, the mesosphere, and the thermosphere. Now, of course, dito tayo hanggang sa troposphere. Okay, dito sa layer na to. Itong layer na to, doon nagpo-fly ang mga plane because as you go up to the stratosphere, you can already find the ozone layer. So sa stratosphere, as you go more higher, pataas ng pataas, umiinit na. You will find out the reason while painit ng painit as you go up. Okay? So mas maganda makita dito sa next slide, yung 4 layers. Ayan. So our base point here is the foot of the Mount Everest. Sea level tayo, sea level, above sea level, and comparing it with the foot of the Mount Everest, here we can find now the troposphere, which is about 10 kilometers above the surface of the Earth. Hanggang dito lang siya, class, 10 kilometers above the surface of the Earth. So yung ozone layer is actually between 20 to 30 kilometers above the surface of the Earth. This is along the stratosphere already. Medyo painit na ng painit dito kasi si ozone nag-absorb na ng UV rays coming from the sun. So as you go higher, nag-i-increase yung temperature. Now, if you are flying along the troposphere, if you try to travel by plane, Habang tumataas ka sa troposphere, palamig ng palamig naman. If you experience already riding in an airplane, going abroad, there is a monitor in front of your seat that registers the temperature outside. So it can go as low as -40 degrees Celsius. Napakalamig. Although air conditioned sa loob ng airplane, in order to balance also the temperature outside, and it is also pressurized. Pressurized yung loob ng airplane to balance also the pressure outside. And of course, para wala tayong maramdaman kakaiba. But if you go up riding in an airplane, as it gets higher, you can feel something inside you. And then after a while, pag nandun ka na, stabilize na sa taas, you will no longer feel anything. Kasi pressurized na yung loob ng airplane. Okay, so let's take up the troposphere. Surface is actually roughly 10 kilometers above the surface of the Earth. The pressure there is about 1,000 hectopascal to 250 hectopascal yung pressure doon sa height na yon. 3/4 of the mass of the atmosphere is found in this layer. Nandoon yung 3/4, 75% of the mass of the atmosphere is found along this layer. So this is where most weather occurs dito sa troposphere. Pagsama ng panahon, if there is typhoon, etc., dito sa layer na ito. Now, the temperature generally decreases with height in this layer by about 6.5 degrees per kilometer or 3.6 Fahrenheit per 1,000 feet or 1,000 foot. Now, the top of the troposphere is called the tropopause. Now, with mid-latitude, jet stream tends to be strongest near the tropopause. So, dito, nag-travel yung mga airplane sa layer na to. Above the tropopause now is the stratosphere, where you can find the ozone layer. Ito siya, oh. If you're traveling by plane, nakakaabot tayo sa troposphere, and above it is already the troposphere. You can already see the blue sky. So, sa stratosphere naman, that is 10 to 50 kilometers above the surface, the temperature constant or increasing with height. Stable but not a lot of vertical mixing and of course dry. Only occasionally kasi nga ang most weather condition kasi nandoon sa troposphere. So dito sa stratus dry na siya. Kasi it is already what you call, the sun is already emitting UV rays na natratrap lang ng ozone layer doon sa stratosphere. So dry na siya doon. Only occasionally get overshooting top from convection pushing into this layer. So yung convection, that is the amount, the heat, we are referring to heat. So why constant temperature and warm with height in stratosphere? Bakit constant or hindi nagbabago or tumataas yung temperature as you go up? As you increase the height in stratosphere. Due to the absorption, ito yung reason, due to the absorption of solar radiation by the stratospheric ozone layer. Nandito na kasi si ozone layer sa stratosphere. So, trinatrap niya na dito yung mga UV rays ng sun that rendered it to become warm. Okay? Ito si ozone layer eh. Ito si stratosphere. And this is the troposphere. Nandito tayo. That this is 0 to 10 kilometers above the surface of the Earth. Okay, si troposphere. Now, the stratospheric ozone layer, paano nagpo-form ng ozone? Paano nagpo-form ng ozone? Which is very responsible in absorbing the UV rays of the sun. So again, the maximum ozone is between 20 and 30 kilometers above the surface of the Earth. Protects the surface from harmful ultraviolet or UV ray radiation. Now, ozone is actually produced photochemically. Anong ibig sabihin ng photochemically? What is photochemical reaction? Define natin mamaya. So, paano nagfo-form ng ozone? So, oxygen molecules are photolyzed. Ang ibig sabihin, when the UV rays of the sun is in contact with oxygen, the tendency for the oxygen molecule is to be splitted into two atoms of oxygen. May split si oxygen molecule, di ba? O2, yun yung oxygen gas, into two atoms of oxygen. So, yung two atoms ng oxygen, step 2, ozone and oxygen atoms are continuously being interconverted as solar UV breaks ozone and the oxygen atom reacts with another oxygen molecule. This is now fast reaction na to. Parang it's a cycle. Magbe-break and then yung oxygen atom magre-react sa oxygen gas, O2, and then magpo-form ng O3. Then, the UV rays again, tatamaan niya ulit si O2 para mag-break ng oxygen. Ma-break yung oxygen gas into atoms of oxygen and then continuously until there is a continuous production of ozone or O3. Now, ozone is lost by a reaction of the oxygen atom or the oxygen molecule with each other or some other trace gas such as chlorine. Saan manggagaling yung chlorine? Kasi pag tinamaan ni UV rays yung ozone layer, kasi nandoon ngayon sa atmosphere, si oxygen, di ba? Nandun sa atmosphere. Ngayon, pag tinamaan ni UV rays, yung oxygen, mag-split yung oxygen into two. Ganon din, mayroon din chlorine na nadi-disintegrate coming from the chlorofluorocarbons na napuproduce natin sa Earth. Okay, you will know what the effect will chlorine do to ozone layer later. Now, the interconversion process converts the UV radiation into thermal energy. Because of this, there is what you call the production of heat energy, heating the stratosphere. Kaya umiinit na yung stratosphere due to the conversion of oxygen gas to and one atom of oxygen to ozone. The interconversion process nagpo-produce ng heat energy because of the UV radiation. So ito na yung photochemical reaction. Do you follow? Okay? Ito yung reaction that happens. Nandiyan pa ba kayo? Are you still with me? Magbi-break
Yes po,
tayo.
ma'am.
Magbi-break
Yes
tayo.
po, ma'am.
12 noon. Magbi-break
Yes, ma'am.
tayo. So, a photochemical reaction is a chemical reaction in which radiation affects the chemical composition of a substance. So, ito yung sinasabi ko sa inyo. Simplified photochemical reaction for ozone. So, the UV rays hits an oxygen molecule. The tendency for the UV is to split out O2 molecule into two atoms of oxygen. Ngayon, itong two atoms of, yung isang atom ng oxygen will react with another oxygen molecule to produce O3 in the presence of catalyst. Yung M dito is catalyst. Catalyst is not affected sa reaction. It only hastens the reaction. Pinapabilis niya yung reaction. It is not affected. Kaya, yung ano mo, catalyst mo, nandun din sa product. So, M is some catalyst molecule. This reaction produces heat at the UV, and the UV is being absorbed. The UV rays of the sun is being absorbed. Now, the tendency now is for the stratosphere to warm up. Iinit na si stratosphere. Okay? Ayun, that is photochemical reaction. Now, of course, nadideplete din sa ozone layer. What are the causes of the depletion of the ozone layer? Take note that ozone is a bluish gas that is harmful to breathe. Now, ozone actually in the water purification process, pag nakikita nyo sa mga water refilling station, one of the process there is what we call ozonation. Yung ozonation, they are making use of an ozone lamp or what we call UV lamp. Nakasabit yun sa water station. Doon dumadaan yung purified water. Yung na-filter na tubig, dumadaan doon sa ozonation. Yun yung UV lamp na tinatawag, na which is capable of destroying or killing the microorganisms present in water. Bago finally it will be delivered or it will be bottled up. Bago ilagay sa container, dadaan muna si purified water sa ozonation. So, of course, there are some water station which do not apply ozonation as one of their step kasi mahal ang ozone lamp. So, sa purifying station, refilling station, some of the refilling station do not have actually this process, but it must have ozonation process. Now, nearly 90% of the Earth's ozone is in the stratosphere and is referred to as the ozone layer. Ozone absorbs a band of UV radiation called UVB or ultraviolet band. Ultraviolet band. Okay? Now, how is the ozone layer depleted? Ganito siya. Okay, ito yung sun, no? Ito naman si ozone layer na nasa stratosphere. Okay? Ngayon, sa surface ng Earth, madami tayong CFCs, chlorofluorocarbons, kang gagaling sa ating mga refrigeration systems, sa ating mga air conditioning units, di ba? Ang dami ng aircons ngayon, almost all households. Meron ding sa mga offices, sa mga school. Imagine how much refrigerants are they using. Yung CFC kasi class, chlorofluorocarbon or HCFC, hydrochlorofluorocarbon, contains chlorine. Ito yung ini-emit ng mga refrigeration systems, air conditioning systems to the atmosphere. So it contains chlorine. Ngayon, if the CFCs are released to the atmosphere, it rises up to the ozone layer. Dito na si ozone layer. Pag na-reach na ni CFC yung ozone layer, si sun, mag-i-emit ng dito UV, it has the tendency now to separate the chlorine from the CFC. Siniseparate niya yung chlorine. Parang yung O2, di ba? Ini-split niya into 2 atoms of oxygen. Pag na-separate na si chlorine, na-disintegrate, chlorine is responsible for the destruction of the ozone layer or the depletion of the ozone layer. Siya yung responsible for depleting the ozone layer. Not only CFCs marami ding mga halons. Yung halons, they consist also of chlorine kasi halons. Those are chemicals that consist of halogens that when released to the atmosphere, responsible also in the depletion of the ozone layer. So anong mangyayari? Na-split na si chlorine, the tendency, yung chlorine, dinidestroy niya si ozone, nagkakaroon na ng thinning, naninipis na or nagkakaroon ng butas si ozone layer. So depleted na si ozone. So more UVs coming from the sun hitting the surface of the earth. So more UV, more skin cancer, more warming up of the atmosphere, and more warming the earth already. So yun, this is how the ozone is being depleted. Nagets nyo kung bakit? Class? Hello? Iniwanan nyo na ba ako? Okay. Oh, kasi chlorine lang na separate si chlorine from CFCs. Chlorofluorocarbon. Chlorine, fluorine are being bonded to carbon. Nakaband siya sa carbon. Ngayon, as much as possible, did you hear about something like freon gas? Alam niyo ba yung freon gas? Pag kayo ay nagpapa-repair ng inyong aircon or refrigerators? Have you heard?
Free po, ma'am. Sa mga
Narinig
sasakyan
na
po.
ba yung freon? Freon is actually the brand name. It is actually chlorofluorocarbon. Iyon yung refrigerant natin, CFC. Pero the brand name kasi is freon. Now, by the year 2020, they tried already to ban the production of CFCs. Pinapalitan na nila ng fluorine, yung chlorine, or ng hydrogen, yung fluorine. Binapalitan nila ng fluorine or hydrogen yung chlorine. Kasi nga responsible si chlorine sa destruction or depletion ng ozone layer. Okay? And as much as possible, hindi na yun ang refrigerant na ginagamit as of this time. Sana lahat na. So this is an illustration of how the protective layer, the ozone layer are being placed or what we call positioned in the atmosphere. So troposphere, nandito tayo sa surface. Planes are traveling through the troposphere. Stratosphere here, protective ozone layer, and then the sun. Now, these are the ozone depleting substances, what you call the ODS. Not only chlorofluorocarbons, not only hydrochlorocarbons, the halones, methyl bromide, carbon tetrachloride, and methyl chloroform are responsible also. That's why itong mga reagents na to, itong mga chemicals na ito, you cannot procure them, you cannot buy them, and for research or for experimental analysis without a permit. Hindi na kami pwedeng maka-order sa laboratory, for the laboratory, ng carbon tetrachloride. Dapat may permit na. And you cannot just throw away carbon tetrachloride, spent carbon tetrachloride in the sink, through the sink. Hindi ka basta, pag gumamit ka ng carbon tetrachloride sa experiment, hindi pwedeng itapon sa lababo. There is a certain there are certain containers that you are going to have para doon mo i-dispose yung mga used chemicals in the laboratory. Because itong mga chemicals na to, pag trino mo sa sink, DENR will run after you. Okay? So may mga agency na nagko-collect talaga ng mga chemical refuse, yung mga waste sa mga laboratories para to take for the protection of our environment. Okay? So let's take a break first before we continue. We stop at slide number 38. Konti na lang class, matatapos na tayo. So break muna tayo. You can have your lunch. Come back after 10 minutes. Harming our body, meaning to say, to protect our health with regards to UV rays coming from the sun. So what are the effects of OLD? Ozone layer depletion, skin cancer, melanoma and non-melanoma, premature aging of the skin and other skin problems, that is darkening of the skin also, mga pigments, pigmentation sa skin, cataracts and other eye damage, immune system and immune system suppression also, and other diseases that is brought about by the depletion of the ozone layer and the absorption of UV rays coming from the sun. So this is now what we call the Antarctic ozone layer, or I mean to say the Antarctic thick ozone hole. The something like yung butas na that resulted from the depletion. The ozone hole is defined as the area having less than 220 Dobson units of ozone in the overhead column. That is between the ground and space. Now, this is what they make use usually for the measurement of the amount or the measurement of how large now is the hole, the size of the hole along the ozone layer. So as you can see from the figure or from the picture, this is somewhat here, okay? So it's just 220, take note of the units, less than 220 Dobson units. All right? And what can we do? Make sure that technicians working on your car air conditioner, home air conditioner, or refrigerator are certified by an EPA or Environmental Protection Agency approved program to recover the refrigerant. This is required by law. Okay, meaning to say when you replace your refrigerant already, make sure that it is the refrigerant originally in there is being recovered. Now, another thing is have your car and home air conditioner units and refrigerator checked for leaks. When possible, repair leaky air conditioning units before refilling them. Another thing, contact local authorities to properly dispose of refrigeration or air conditioning equipment. Yung mga sirang mga AC units and refrigerators, they should be disposed of properly. Protect yourself against sunburn. A minimum sun exposure during midday hours between 10 a.m. to 4 p.m. Ito yung time na nag-emit ng harmful UV rays ang sun. 10 a.m. to 4 p.m. Now, wear sunglasses, a hat with a wide brim, and protective clothing with a tight weave, especially those who are working in broad sunlight. Use a broad spectrum sunscreen with a sun protection factor SPF of at least 15 and 30. Pag nakikita nyo yung mga bumibili kayo ng sunscreen, mayroong SPF 15, SPF 30. So, okay na yon 15 and 30. Pag bumili kayo. Now, I'm going to ask you, can you still remember the component of sunscreen that we took up when we are taking up nanomaterials? Ano na yung component na nanoparticle? In the size of a nanoparticle? Can you remember?
SPF 13, ma'am.
No, the component, the compound present that is added sa mga sunscreen. Nakalimutan nyo na?
Opo.
Titanium dioxide, remember? O, pakibasa nyo ulit ha, pag nag-review kayo. We include nanomaterials doon sa exam. Molecular materials. We have nanomaterials. Part 2 molecular materials part 2. We have nanomaterials, composite, cement and concrete, semiconductors. Ayun. Then, term 1, part 1. So, ito na yung mga pointers. We are done with this already. Any question before we go along with the pointers and the seat work? Any question dito sa part 1 ng ng environmental chem? Walang tanong? We are done with it already. 42 slides. No questions? Hello?
Ano po?
Nan po, ma'am.
O, sige. Mag-sit work na tayo. But before
Ma'am, pwede
that,
pa ulit po ng pointers, ma'am.